Okay guys, today we're doing 5.7 and we're doing a beginner related rates. So with the next few lessons they'll get more and more difficult. This is just the start. Let's begin. Okay, first off, these are the rules to doing all of the related rates. Okay, so I would write them down. Whoops, sorry, going back. I would write them down and we're just going to continuously use these, and I will go back to these 5 rules for every problem we do. Okay, at least I'll try to. Okay, so the first one, uh, if needed, draw a picture. If you can't understand what's going on, I would draw a picture. After that, find the formula that you're gonna be needing. Okay, so you'll notice the things that you're given, and you can probably figure out what formula you need based off the things you're given and the thing that you need. Um, uh, this step is optional, but I always suggest to do it. Plug in any non-changing variables. This is going to make your life a whole lot easier. If there's something that's not changing, plug it in. Okay, after you've done that, differentiate the formula and solve for whatever it is that you need to solve for. So let's do some problems here. Okay, grab my pen. A rectangle's length is increasing at a rate of 2 inches per second. Okay, now I'm also going to draw the picture and I'm going to label these guys. I showed you guys how to label them in the last lesson. Okay, so that's the change in length divided by the change in time. So I'm going to call that dl over dt. And that's going to be, it's increasing, so 2 inches per second. Okay, and its width is decreasing at 3 inches per second. Okay, so that's going to be my change in width over change in time. Since it's decreasing, it's going to be negative 3 inches per second. Okay, find the area's rate of change when the length is 7 and the width is 6. Okay, so we are looking for the change in area. So we're looking for dA over dt. I'll put a little question mark because that's what we're looking for. It also gives us the length we have, which is 7 inches, and it also gives us the width, which is 6 inches. Okay, so let's draw a little picture here. We got a rectangle. Okay, the length is changing at 2 inches per second, so that means that it's increasing in length, so that'll be a dl over dt. And this will be my length. And I got all this stuff written over here if you want to look at what they stand for. And this will be my width, and the width is decreasing, so it'll be going that way. Yeah. Okay, so looking at this, so either based off of the variables you have or the little picture you've drawn, you should be able to figure out what formula you're using. In this case, we're talking about the area, right? We're looking for the change in area. So I'm going to use the formula for area of a rectangle, which is going to be area is equal to length times width. Okay, now we are looking for the change in area. The only way to figure out change in area is by taking the derivative of this, right? So let's follow our rules here. The first one was draw a picture. I got it. Okay. The second one was label everything. The third one is the second one is find the formula you need right here, right? The third one is plug in any non-changing variables. Okay. Well, width is changing and so is length. So there is no non-changing variable here. So I can skip step 3. Okay, step 4 is take the derivative of the formula. So dA over dt is equal to, okay, this is product rule, yeah, so rewrite the first one, take the derivative of that one, dw over dt, plus, since it's product rule, rewrite the other one, and take the derivative of that one, which is dl over dt. Okay, take the derivative, and then solve for what it is that you need. That's the last step. Okay, well, we have everything. We're already solved for the change in area, which is what I'm looking for. And I have all of these things, so let's just plug in and get our answer. So the change in area with change in time is going to be the length, which is 7, times the change in width, which is -3. So that's going to be -21, plus the width, which is 6, times the change in length, which is 2. So we got -21 plus 12, and that'll give me -9, right? That's -9. And we also want to make sure that we use the correct units, okay? Units are important. Area, what is area? This is the easiest way to figure out your unit. Look at what area is, and how would we measure area? Area would be in inches squared. Inches squared per, and time is on bottom, and time is measured in seconds on all this. So the area is decreasing at 9 inches squared per second at the point at which there is the length is changing. The length is 7 and the width is 6. Okay, now if I would have asked about a different length and width time, then it might be different. This number might be a different answer, okay? So there's your answer for that one. Let's do, I believe I have one more here, and let's walk through our steps again. Okay, first one is let's label the things and draw a picture. Okay, so a right triangle has the sides 30 and 40 inches that are changing. Okay, so I have a right triangle. Okay, a right triangle. It says as the lengths 30, the side lengths 30 and 40. And they're both in inches, okay? So notice you could write them on the side like how I did on the last problem, or you could draw your picture and label them on the picture. It's really up to you. They're changing. Find the rate at which the hypotenuse is changing. Now this is my hypotenuse, right? This area right here. And we're looking at the rate at which it is changing. Okay, so this is my hypotenuse. I am looking for dH over dt. That's my goal. Is changing if the short side is decreasing at 3 inches per second. Okay, well this is the short side, so it's decreasing at 3 inches per second. And the long side is increasing at 5 inches per second. Okay, so now that I got everything, my picture drawn and everything labeled here, my next step is to find the formula I'm going to be using. Well, what I would hope you notice here is we're talking about all the side lengths, and that is going to be Pythagorean theorem. So if you know your Pythagorean theorem, that's going to be a squared plus b squared equals c squared. Okay, there's the formula that we're going to be using. Okay, step 3. Is anything not changing? Well, this is changing. The 40 is changing. It's increasing at 5 inches per second. The 30 is changing. It's decreasing at 3 inches per second. And if those two things are changing, then this definitely means that this hypotenuse would be changing as well, which is what we're going to be looking for, right? Okay, so step 3 we can skip. Step 4 is take the derivative. So the derivative term by term. Derivative of this is 2a dA over dt. And I should probably label my stuff here. Let's call this my A side, yeah? Plus 2b dB over dt. Okay, I'll call this my B side. So then that means that this is going to be the change in A, and this is going to be the change in B. Okay. Okay, and then let's take the derivative of that last term there. 2c dc over dt. Okay, so that means my hypotenuse, I'm not going to call it h, but I'm going to be calling it c, yeah? So let's ignore that. Call it c. Same thing here. This is going to be the change in c is what we're looking for. Okay, so we took the derivative. If you notice here, there is a step we can do right here before we start plugging stuff in. There is a 2 in every single term. What you can do is divide by 2, yeah, from this side, and it'll cancel every 2 out. Yeah, so our answer is, or well, not our answer, but our formula is actually a dA over dt plus b dB over dt equals c dc over dt. And that just makes it so we don't have to deal with that 2 that's in there everywhere. If you left it in there, it really wouldn't matter. Okay, let's plug everything in. That's what step 4 is, right? Step 5 is a plug in and solve, right? So let's see what we get here. So A is 30. The change in A is -3. So that's going to be -90. plus B is 40, and the change in B is 5, equals C, and the change in C. Okay, now we don't have C or the change in C. There's two variables we don't know. There should only be one variable you don't know, okay? If there's any things missing, that means you can figure them out, okay? Now I'm going to repeat that. If there's ever anything missing, like you need C in order to solve for dc dt, that means you can figure it out by looking at the problem, okay? Now, we can use Pythagorean theorem to figure out what C is, okay? So that would be 30 squared plus 40 squared equals C squared, right? And that means this would be 900, and there's a much easier way to do this right here. This is a Pythagorean triplet. I know the answer's 50. 3, 4, 5 is a triplet, so 30, 40, 50 is a triplet. I mean, you don't have to memorize that, but you can. And my pen doesn't allow me to write here, so I'm going to have to write over here. So that's going to be 2500 equals C squared, and then you square root that, and that's going to give us C is equal to 50. Okay, so that's what C is. It's 50 inches. So that's going to be right there. And then times the change in C, which is what we're looking for, right? Okay, so let's just figure this out. It's going to be negative 900 plus 220, right? Oh, I'm sorry, this is not 900. I'm still thinking about this problem over here. It's negative 90 plus 20. I'm sorry, 200. I'm going crazy over here. Sorry, guys. Equals. Okay, that's going to be 50 dc over dt. Okay, that's going to give us 110. Okay, guys. So that and that would make 110 equals 50 dc over dt. And we can divide by 50. And that gives us dc over dt is equal to 110 divided by 50. Cancel out those zeros. It's going to be 11 over 5. And then make sure you use the correct units. C is measured in inches per time is measured in seconds. So you can look at this in two ways. You can say that this the hypotenuse is changing at 11 inches for every 5 seconds, or you can say it's changing at 11 over 5 inches per second. Yeah, and that's going to be our answer. That's how you do the beginning of related rates, and I wish you all the luck.